So question 12. Solution by graph sketching is not accepted. A particle moves along a straight line such that its velocity v meter per second is given by v equals to t cubed minus 4t squared plus 3t, where t is in time, in second. So after passing through the fixed point O, find the initial accelerations in meter per second square of the particle. Initial acceleration, that means when t equals to 0. Okay, and this part A gives us 2 marks. Part B, the time interval in seconds when the accelerations of the particle is less than 6 meter per second square. And this question gives us 2 marks. The time in second when the particle stop instantaneously when v equals to 0. Okay, stop instantaneously means that v equals to 0. And this question gives us 2 marks. D, the total distance in meter traveled by the particle until the particle return to the fixed point O for the second time. This part gives us 4 marks. So total up, we have 10 marks for questions 12. Alright, so let's take a look at A first. Alright, so 12A. Okay, accelerations. We are given the velocity formula, which is v equals to t cubed minus 4t squared plus 3t. So from here, we can generate the accelerations equations by differentiate the velocity. So A will be equals to dv dt, which is 3t squared minus 6t plus 3. So initial acceleration, that means when t equals to 0, A will be equals to 3 meter per second square. Okay. B, the time interval in second when the acceleration of the particle is less than 6 meter per second. So that means dv dt less than 6 meter per second square. So I can get 3t squared minus 6t plus 3 less than 6. Okay, I rearrange it, I will get 3t squared minus 6t minus 3 less than 0. Factorize it, less than 0, 3t plus 1, t minus 3. Alright, so from here, let's draw out the graph. Since this is inequalities, so this one is 3 seconds, this is 1/3. So less than 0. Okay, we are looking at here. So therefore, the value of t is less than 3, more than 1/3 second. Okay, so this is a time interval. So part C, the time in second when the particle stop instantaneously. Okay, so that means we are using the velocity. Okay, the velocity formula, which is when v equals to 0, t cubed minus 4t squared plus 3t equals to 0. We factor the t out, I will get t squared minus 4t plus 3 equals to 0. And then we can factorize this. T equals to 0, t minus 1, okay, t minus 1, t minus 3. So therefore, I have 3 values for my t. So first one is t equals to 0 second, or t equals to 1 second, or t equals to 3 seconds. Okay, part D, total distance travel. Okay, bear in mind that total distance travel and displacement is totally different. Displacement, that means from the origin to the end point, what is the distance? Okay, total distance travel is that the distance, how much did the particle travel, how many meters did the particle travel. So in this case, it is say travel by the particle until the particle return to the fixed point O for the second time. Okay. Second time, we know that from question C, we know that the first time it is at 0 second. The second time is at 1 second. Alright. So that means what we can do is, okay, sorry, from part C, V equals to 0. That means at t equals to 0 second, the particle change the directions. When t equals to 1 second, the particle change the direction again. When t equals to 3 seconds, the particle change the direction again. But doesn't mean that it passed through the fixed point O. Okay, this is the information that we got from C is very useful for our D. Okay, so part D. So how do we find out whether the particle going back to the origin, passes through the origin, is that we can use the displacement equations. So how do we get the displacement equations? So S equals to, we integrate V dt. So that is integrate t cubed minus 4t squared plus 3t dt. This is an undefined integral. Bear in mind that when you are doing with undefined integral, please add a plus c at the end. Okay, so this will be 4 power t power 4 over 4 minus 4t cubed over 3 plus 3t squared over 2 plus c. Okay, so let's find out the value of c. Okay, we can find it at here. Okay, it's given by v equals to t cubed minus 4t squared plus 3t, where t is the time in second after passing through the fixed point O. So that means when t is equal to 0, s is equal to 0. Thus, when s equals to when t is equal to 0, this term 0, 0, 0, s is equal to 0. So that means c is equal to 0. Therefore, my displacement equation will be s equals to t power 4 over 4 minus 4t cubed over 3 plus 3t squared over 2. Okay, now we have the displacement equations. So how do we find the total distance traveled? Okay, we need to find out that at what time the particle passes through the origin. That means displacement is equal to 0. So when s equals to 0, my t power 4 over 4 minus 4t cubed over 3 plus 3t squared over 2 equals to 0. Okay, and then what I can do is we use 12. Alright, and then 3t power 4 minus 16t power 3 plus 18t squared equals to 0. Right? 12 cannot be equal to 0. What I mean is the denominator cannot be equal to 0. Definitely 12 does not equal to 0. So the only thing can be 0 is the numerator. So 3t power 4 minus 16t cubed plus 18t squared equals to 0. And then I can factor out t squared, which I get 3t squared minus 16t plus 18 equals to 0. And then let's see whether can we factorize it. Okay, in this case we can't factorize. We need to use by formula method. So the formula will be minus b plus minus b squared minus 4ac over 2a. Okay, so in here t can be equal to 0, and then t equals to minus b, so it's 16 plus minus b squared minus 16 square minus 4, a is 3, c is 18. divided by 2a. 2 multiply 3. Alright? So in this part, t can be equals to okay, let me put it another way around. Instead of writing plus minus, this I put plus, and this I will put 16 minus 16 square minus 4 AC over 2a. And this, you can press your calculator and you will get what? 3.72 second, and this is 1.61 second. Okay, from this equation, it means that at t equals to 0, the particle is at the origin, meaning the starting point. And when t equals to 3.72 second, the particle passes through the origin, the O. When t equals to 1.61 second, the particle passes through the origin, which is the O. Alright? So in order for us to find the particle return to the fixed point O for the second time, the first time is this one. The second time is this one. So that means we need to integrate from 0 to 1.61 second. However, in question C, do you still remember the question C that we talked about just now? At t equals to 1 second, the particle changes the directions. So that means when we integrate it, we need to separate 2 times. So what it means is that total distance travel is what? Integrate 0 to 1 v dt plus integrate 1 to 1.61 v dt and give us what? Integrate 0 to 1 t cubed minus 4t squared plus 3t dt plus 1 to 61 t cubed minus 4t squared plus 3t. Sorry, this is not ds, this is dt. And then what we get is t power 4 over t minus 4t cubed over 3 plus 3t squared over 2, 1, 0. Plus t power 4 over 4 minus 4t cubed over 3 plus 3t squared over 2. This is 1.61, this is 1. Okay, bear in mind that you need to put a modulus, okay? Because you might get a negative. If you negative, you will cancel out your answer is not correct. Alright, so in the end, if you use your calculator, you will get what? 10.12 meter.